Today we're going to be looking at Prerequisite Skills Lesson 8. This is the culmination of so many different topics from Alg 1, Alg 2, Pre-Calculus, trigonometry, all of it. We need these skills in order to advance in calculus. We'll still have some linear and quadratic solving, but a lot of them will go back to different trig functions. So we're going to do a couple things with this lesson. We're going to go through all the problems. We're going to talk about unit circle answers. You will have to think out some of the answers, but we're also going to compare and contrast what it is that we're given. Let's take a look at the directions so that we understand what they are looking for in their answers. Solve all of the equations for the variable x in the interval 0 to 2 pi. X in this case also could be t in some textbooks, and this tells me that I want my answer in radians. Or theta on the interval from 0 to 360. In this case, theta is going to be answers in degrees. What this means is that we want one revolution of the unit circle when we give our answers. If we look at example 1, A1, and we read through this, we can rewrite this without the trig terms. If we rewrite it, we get the following. 2s squared minus 1 equals 0. Analyzing this tells us that this is a quadratic equation. We have everything on one side equal to 0. We could factor, but since there's no difference of squares and we don't have a middle sine x term, we're going to actually use the square root method. So I'm going to move the 1 to the other side. I'm then going to divide both sides by 2. Puts me right about here. My next step is to take the square root of both sides. Recently we had done the Pythagorean theorem, but one of the things about the Pythagorean theorem is that distance is always positive, so we forget that we actually generate two solutions through the Pythagorean theorem, plus or minus the square root. This is important because when we take the square root of both sides, we get plus or minus, and then I can split the root up. From here, I can rationalize my denominator. So I'm going to multiply top and bottom by root 2 over 2. I'm not allowed to leave roots in the bottom. So that tells me that the sine of x can be either the plus or the minus root 2 over 2. This simple trig equation is what we're going to think out using the unit circle. If you recall, the sine of x is the y value on the unit circle. So I'm asking myself, where on the unit circle do I have a y value that is either positive root 2 over 2 or negative root 2 over 2? That occurs at all of the 45s. Now, if we reflect on the initial statement in the directions, we were given an x, which tells me my answer needs to be in radians. So x is going to equal pi over 4, which is here, 3 pi over 4, 5 pi over 4, and 7 pi over 4. There are 4 solutions for x. Now, just to clarify what it is we exactly did, if we go back to here and we plug in the first pi over 4, is the sine of pi over 4 equal to positive root 2 over 2? Yes, this is true. That means we found a value of x when we plug it into the equation that gives us a true statement. That's the definition of a solution. We could plug in 3 pi over 4, 5 pi 7, and either get a positive or negative root 2 over 2. Both signs can be included. If we move to example 2 on the right-hand side, and we get rid of our trig, we get tangent plus root 3 equals 0. This is an example of a linear equation. Linear equations are found by isolating just the linear term. So we can do the same thing here. Tangent of theta is equal to negative root 3. This is where the video really helps in order to hear the thought process that you should have. Tangent, we worked many times over where we would take the y value over the x value. Okay, and these, remember, are the xy's of the ordered pairs of the unit circle. When we would set that up, we then would simplify. We could cancel denominators and work our roots over. So this is the final simplified answer. Mathematically, we can work backwards. We can say, well, this is really over 1, because anything over 1 is itself. And knowing on the unit circle that the only values we can have, if you remember this schematic, are 1/2, root 2 over 2, root 3 over 2, positive and negative forms of all of these, what we have here, if we're thinking them out in the unit circle, has to come from here, which tells me this originally was over 2, as was this. So this statement that I'm putting a bubble around has two different forms. Either the tangent of theta is equal to negative root 3 over 2 over 1/2, where this is y and x, or we can have root 3 over 2 over negative 1/2, where this is y and this is x. On my unit circle, those two happen at either here or here. Now, if you recall from the directions, I'm dealing with a theta, so that means I want my answer in degrees. This location is 120 degrees. This location is 300 degrees. And I'm done. Compare and contrast. 4 answers here, only 2 answers here. That's okay. Moving on to the middle section. Really, really important rule that we need to write down on our paper from the beginning. You must never, and I'm going to say never, ever, divide out a trig term. Never. So what I mean by that is that when I look at this problem, my brain tells me just divide both sides by sine, it'll simplify it. Not going to happen. We need that sign there, and you're going to see why in a second. The strategy that we need to take is to take this sine of x and move it to the other side. That gives me 2 sine theta cosine theta minus sine theta equals 0. Now, take a look. Here's my first term. It's pretty big. Here's my second term. I'm going to use GCF strategy with 2 terms. I don't have any quadratics. Okay, so I don't have any squared terms. So my GCF in this case is going to be sine theta. When I take that out of the first, get rid of sine theta, it leaves me with 2 cosine theta. When I take the sine out of the second, out of here, it leaves me with a minus 1. Right? Now, way back when, you should have learned about the zero product law. The zero product law says quantity times quantity equals 0. Either the first quantity is 0 or the second. As long as one of these takes on the value of 0, when you multiply it, it will come out to an answer of 0. There is no other product law besides the zero product law. So, if this is my GCF out front, I can say, well, sine theta could be the 0, or 2 cosine theta minus 1 could be the 0. In other words, take each of those, set them equal to 0, and solve. Sine is going to be the y value, so I want to know where's the y value 0 on the unit circle. Y will be 0 here and here. If I solve this, I get cosine theta equals 1/2. So the question is, where is x equal to 1/2? That's going to occur up top here and down below here. And now I'm going to set up my solutions. Theta means degrees. So again, we can note up top here that I want to answer them in degrees because I'm dealing with theta. My 2 solutions here are 0 degrees and 180 degrees. My 2 solutions here are 60 degrees and 300 degrees. Here's an example where we have 4 solutions. Now, when I look at A4, this problem, I think there's a lot of you that are going to think, I should FOIL this. I know how to get rid of parentheses. However, if you take a step back, I actually gave you a very simple problem already in zero product law form. So if we compare this to this, we can see we already have the two quantities that we can set equal to 0 and solve. Cosine x equals 1, sine of x equals -1. Where does the x value give me 1? Well, that's going to occur here. And where does the y value give me -1? That's going to be down here at the bottom. So when I go to solve for x, which again is going to be in radians, I'm going to get 0 pi or 0. The answer it should never be is 2 pi or 3 pi over 2. Moving to the bottom. If we take a moment and look at these two separate problems, there are some similarities to them and some differences. One thing to notice is that in my first problem, do you notice I have secant squared, secant, and a number? That sounds to me like quadratic form, ax squared plus bx plus c. But secant squared and secant are the same trig expressions. Over here I have a sine squared and a cosine, so I have a quadratic and a linear term, but these are not the same trig. Also over here I have this equal to 0, whereas over here I have it equal to 1. If you remember, from up here we talked about the zero product law. There is no one product law. So in order to use this method of solving, I have to have it equal to 0. Let's solve the first. If I write this in a little bit more pure algebra sense, I think you recognize that we could then factor equal to 0. This is a quadratic equation that we could then solve. We're going to do the same thing here. We're going to set up our quantities. Secant x times secant x. What two numbers multiply to give us -2, but add to give us 1? Plus 2 minus 1. Check your outer and inner multiplication to make sure we have the same correct middle term. Set each equal to 0. Solve. And now we get to a little bit of a tricky situation. If you remember from the unit circle, secant goes back to cosine. Cosine is x, so 1 over x has to take on the value of -2. When we solve this, same thing here, 1 over x has to equal 1. We can solve this by putting this over 1 and cross multiplying. 1 is equal to -2x. X is equal to -1/2. That's what we're looking for. Solve this one, we get x is equal to 1. All right, x equals -1/2 here and here. X is equal to 1 is going to be here. So I know I have 3 solutions. Because I switched to x, please remember we're going to go back to radians. So x is going to equal 2 pi over 3, 4 pi over 3, and over here at 0 pi. When we move to the next problem, we cannot solve this when we have 2 different ratios. So we need a way to take sine squared x and convert it into cosine. And because we have a squared, the easiest is to use a Pythagorean identity. 1 minus cosine squared x minus cosine x minus 1 equals 0, where this is my substituted Pythagorean identity. Now I need to do a little bit of algebra. 2 minus 2 cosine squared x minus cosine x minus 1 equals 0. And now we have this phenomenon where we know we are on track for this to look very similar to this. But if we want to factor, most of us like to factor when the quadratic term is positive. My quadratic term is negative. So the easiest way for me as a math teacher, rather than multiplying everything by 1, is to move everything to the right. So when I move this to the other side, I get 2 cosine squared x. When I move the negative cosine over, I get positive cosine x. If I combine like terms here on the left, I get positive 1. But when I move it to the other side, to the right, it becomes a negative 1. From here, I can factor. So now it's starting to get into the same pattern as what I've seen before. I did the legwork up here to get it all into the same trig expressions. 2 cosine x, cosine x. Think of your outer and inner multiplication. Plus 1 minus 1. Set each equal to 0. Cosine x equals 1/2. Cosine x equals negative 1. Where is that going to happen? Negative 1 would be here. These two are my little bit of x 1/2. So now my answer for x, I'll do this on this side. Again, we're going to talk about radians because you were given x's. My answers are going to be, starting here at the top of my unit circle, pi over 3, moving around to pi, back down to the bottom, 5 pi over 3. The assignment for tonight consists of Delta Math introductory problems, and then there's also a worksheet in the IP section of Google Classroom that needs to be submitted, which I will grade using the class rubric.